I'm going to share something about me, and in that case, so just let me share this data so that we're able to connect with what we had started last time. And the whole of this logic is based on the fact that we had started a presentation on Dahua Bank Solution. So when we were doing this presentation, we had a previous recording, a previous series. So if you missed that one, I'm inviting you to come and join it, so that you're on the same page. So first I'll have to reintroduce myself. I'm Zephania Mwando. Currently I'm a pre-sales engineer for Dahua Technology Kenya. And what I'm going to cover today is going to be, so if you just try to search for me, you'll find the result, and then I'll open the YouTube video link, and the whole objective is to show you the exact solution that we had in the past. So we have this solution, transforming banking with Dahua's IoT solutions. So if you did not join this training, then I'm inviting you to first go and follow this after this training, so that you're able to connect with our series on banking solutions. So allow me to switch back to today's subject, and we are going to cover two topics today. We are going to look at video compression as per the Dahua standard to meet the financial approach in banking. So I hope you can see my presentation, and this is how it goes. So we call it the QLIN video compression solution. QLIN video compression, we are looking at as perspective of quadruple low bandwidth video compression. And this whole point, we're going to cover the background, we're going to cover the requirements, we're going to cover the solution design, we're going to highlight the solutions, and also look at some success cases on the same. So starting from the background of this whole logic, we have the traditional trend in networking, and you find that it is hard to do even integration. Also looking at banks, they are actually rigid. So playing these policies makes it very hard, and also doing emergency response may seem to be a challenge. Then again, the biggest challenge you have with banks is the cost of the bandwidth. So banks have high bandwidth requirements, but they will always prioritize on having low banking operations first, then we can add the other things. So it's hard to change the bank's existing network system due to high security requirements. At the same time, the cost of having to maintain this bandwidth is high. Now, what solution do we as Dahua give? We give the QLIN solution. The goal is to help with the bank's own system, reduce code flow, and achieve the purpose of central monitoring within the bank branches to headquarters. Q stands for quadruple, L is for low bandwidth, I is for intelligent, and N is for network. So what are we really talking about? So highlighting the challenges, we have a preview of videos. In most banks, actually, let me talk about a case in Kenya. It's just 2 to 5 Mbps for most banks to branch. Now, 2 to 10 Mbps may be relatively really low. If you're running, let's say, more than 16 cameras of 2 Mbps, then you need at least For live view and playback, you need at least 16 times 2, 32 Mbps. Just for a simple playback, you can't even fast forward the playback and such things, because if it's fast forward times 2, it means it's doubling the bandwidth consumption. So looking at that, we need at least that 32 plus maybe 8, which is 40 Mbps for a smooth stream. And remember, this 40 Mbps is supposed to be dedicated to CCTV, not for bank operations. So if they add again bank operations, they have a very high cost of bandwidth. Then another thing is you can't preview the same channels at the same, multiple channels at the same time because of the same cost. Then if you look at the cost of bandwidth or the cost of internet providers per month, you'll find the upgrade cost for your bandwidth would be really high, which may not be a friendly thing for the bank. Now, moving on, let's analyze the requirements. We have bank policies, and these policies require that banks should have data at least 3 months. That is just one of those policies. We have things like things like the recording period 120 days. We have some things to do with the compression. So many policies revolving around the data. And then we also have the GDPR, that's the gross domestic organization checks. So with this, you find it so hard to manage. Then they need to comply with all their standards. So with all those challenges, we come to what are the customer requirements. Number one of those requirements is we need to look at the network monitoring aspect. We have the video recording compliance. We have AI applications for the same. So for video recording compliance, as per the regulation, standard compression is H.264 and H.265. If you don't understand these standards, then I'm inviting you to our certification training where you learn more about the video compression and all that technologies. Then we have AI applications. So we can use AI to enhance surveillance efficiency in the sense of using AI to get better filtering of images and events so that we don't just get all our incidents dumped on us. Then we look at how do we design our solution. Technically, this is how we look at it. This is our topology. So we have a central platform which does management, operation, and maintenance and saves on computing resources. But still, this runs on a bank private network which is secure actually. Then we offer a 4-in-1 intelligent compression and VR, which gives us a low bandwidth solution. So we reuse the original high definition camera on the network, but use the compression and VR to achieve sending data to the client. Now let's compare these compression standards. H.264 each block size 16 times 16 frames, while H.265, it breaks it down in a better way so that we have 8 by 8. So it's looking like on H.264 coding, if we are consuming 1 TB, then on H.265, we're going to save 50% of that based on video compression technology. For you to understand better about our video compression technology, please consider attending the basic video surveillance certification. Then you learn more about this and it will be useful. Then when we look at compression logic, if we have a camera monitoring this area, compression is achieved when we maintain the main background frame or the background image because it's not going to change, and only record the changing aspects. Like if this bus is moving from area A to area B, then we only record that bus and overlay it over the same scene. That helps us because instead of having 50 images with the same thing, we just keep one image and record the small details using the compression. So with this, we save on space. Now, some cameras require, we have the dual streaming technology. So we have the standard stream and the compressed stream. So it's like compressing the stream and then we send. We do the standard stream, we also send. And generally with dual streaming, we're able to store the original video stream for playback and evidence retrieval. Then we can compress the live stream for remote viewing, especially if we are monitoring many branches, then we can compress it so that we reduce the load on the bandwidth that we have. Then we introduce our solution of QLIN server compression test. So we have live monitoring. So banks recording at H.264 25 frames and 4 Mbps. That requires single 6 Mbps considering fluctuation that occupies the network bandwidth. With a QLIN server, we can achieve a compression of about 75 to 95% bandwidth. Let me just call it a 90% bandwidth compression. So if I was doing 6 Mbps, we now are doing it at 1 or 1.5 Mbps. So this reduces the load on our bandwidth as a solution. Then we have remote tour monitoring. So when monitoring center conducts remote inspection, we increase consumption on the bandwidth. So if we are doing that, then it means we need to compress this so that we save on that space. Then in some banks, they also have an extra video, which is always doing live view of the branches. So when we are doing that, we're also consuming bandwidth. So bandwidth is consumed into three aspects: live monitoring, remote tour monitoring, and video monitoring. Now, to save on the cost, we introduce the QLIN solution, and we have a QLIN server that does this. So let's now try to compare the compression ratio during day and during night. So we are using a standard of 1080p vehicle or a 2 megapixel. Just briefly excuse me for 1 second. Okay, so sorry about that. So we are doing an analysis on bandwidth compression, and looking at it, we are looking at daytime 2 megapixel on multi-lens, multiple vehicles and people. So look at this. H.264 is 8. Then we compress it. It becomes 646 kbps. Then that compression ratio is like 91%. Multi-vehicle and people H.265, 8021 kbps. We compress it to 499. Just look at this. At night when there is less activity, H.264 is 4 Mbps or 4059 kbps. We reduce it to 69, and H.265, we save it to 43. So that's 98% compression. So this gives us an average of 90% compression based on the activity and the camera compression standard. So this going to help us to save on space. And we compare, like we have high definition video compression based on the traditional, this is the traditional video compression, which is dynamic and adaptive to the scene. but the mainstream is like 2 Mbps, compressing the code to 600 kbps. So if you compare the image quality for this, it means that the bitrate is going to be a little bit high because there's so much activity. You see there so many moving targets, so the compression may not be as efficient as an area where it's more static, less activity. So if you compare this, even we have the statistics, 2 Mbps uh, compressed to 412 kbps using the Dahua QLIN server. So for outdoor environment, the compression may be relatively lower because of the more activity that we have. But in an indoor scenario, we have video compression being more efficient because look at the moving targets. There are less targets, so less activity and all that. So we save more bandwidth in areas where there is less activity compared to where there is more activity, because that's how the compression algorithm would work. Then we have remote tour monitoring. So this is a typical remote tour monitoring that we are trying to analyze in a bank. So if you look at this, you'll see here there's some activity, here there's more activity, this kind of. So if you're doing this kind of recording, in the original stream will consume more compared to the compressed stream tour. And if you look at the video quality, even on the original stream, comparing with the compressed stream, you'll see the compressed stream is really smooth. Look, this video is stuck. This is stuck. But in this case, this video is moving, like the targets are moving in a compressed stream. So it means that the implication on bandwidth is significant based on using a QLIN server to do the video compression. So where does this QLIN server sit? The QLIN server sits at the branch level. So we install a QLIN server on each branch. Then at the headquarter, we get the streams. Then we have multiple AI applications that we'll get from this QLIN server. Things like mobile phone use, unattended cache, counter door opening, important objects that are protected, maybe attending to a phone, a counter that is unattended, we can trigger alarm so that the actual person fits. Then we have at the ATM, we are going to also look into more detail about this ATM. At the ATM, we check things like wearing masks, trying to scheme or scam the ATM, some fraud, maybe over the phone, robbery within the ATM, we trigger the alarm. And this actually fits the banking industry's operational and security needs. And we have applications that we can also customize this solution as required by the bank. Then we have video quality diagnosis. So the monitoring center has a struggle going through this kind of quality because there is noise, there is blur, abnormal brightness, and such things. So our QLIN server would help to sort this kind of thing because it will report such kinds of issues. There is a blur on this video, abnormal brightness, and then the technician can respond to this so that the end result is you get the best out within the same branch. So this is the main product that you get for QLIN compression. So it's IVSA 7008C and AVSA 701, but it has 2I at the end. So it's specifically designed for this kind of solution. Then let's look at the highlights. So we have smart compression, the highest with 90% efficiency. We improve the video quality. We have dual streaming support so that we can still record our normal video and still do live stream remotely with QLIN. Then the AI applications. So we have a 4-in-1 low bandwidth intelligent network solution for the finance industry. So let me just play this short video. So that covers like a brief preview of the highlights of our solution. Then let's look at some cases where we've applied this. So in China, we have Bank of China, where we have QLIN, and we have compressed more than 700,000 channels. So you can imagine that's a very big uh, compression solution. So if you need this, then you are welcome to try it. And because of time, I'm going to move to the next part of this presentation, which is the AIoT ATM ATM AI solution. And in this solution, we are going to look at, for the same series of the bank, we now look at a specific case guided, and it is the ATM of the bank. Now at the ATM, I'm going to cover this, the background, the design of the solution. We look at the subsystem solution, and then the case on the same. So we have so many security incidents where main challenge is ATMs getting attacked, maybe through robbery, people sleeping near the ATMs, vandalism, fake keyboards, skimming, hackers, and all this. So we need to provide a solution because as per the international regulations, we need to secure our ATMs and make sure that they're actually efficient in providing a security solution to the banks. So the analysis is, as per the customer, we have incidents, attacks, and changes. And this makes the bank to require to provide security in the ATM, settle transaction disputes, and improve the general efficiency of the ATMs. And how we do this is, we do smart video protection, video surveillance. We have smart alarm protection. We have intercom on the ATM. We have POS information overlay. Then we have the platform, the management platform for this. So how do we design this solution? So in the ATM, we can run face recognition so that we can filter VIPs. We can filter people in the blacklist and such. Then we model this during when there is that is before the incident happens. During the incident, we have an alarm triggered. Let's say the vibration detector triggers the alarm. We have a pop-up at the monitoring center or at the security center. We also have remote warning that whatever you're doing is being tracked and such things. This remote warning also has two-way intercom where if I'm attacked within the ATM, I can also press the panic button and someone would call in the ATM. Then after the event has happened, we can always do playback and handle the alarms based on the actual case. Then for this solution overview, we have the platform which does the regulation. We add a wired alarm system. We have a two-way intercom system within the same ATM area. Then we have the handling of financial disputes. Then we also have video AI system protection for the same ATM. So the network topology is on each branch or on each ATM, we'll do video surveillance using our pinhole cameras. We also do the normal camera, we do the behavior analysis within the ATM. We also add the alarm box inside the alarm, and to get the ATM landing area or the management area, we have face recognition, access control. Then with this, we can link connect this to go to DSS Pro, which is accessed by DSS client. We can do live view. We can also do a view at the branch monitoring center. This DSS Pro can trigger these alarms and even send to enforcement if you want to integrate. Then the solution for the ATM subsystem. So we have precise detection and visual alarm. So things like low-tech skimming, high-tech hacking, mask detection will use Wizmind and VRs to do this kind of deterrence and solution. Then we have visual and proactive security where we do a wired alarm scenario. In this case, we have alarm pop-ups and then responding to these alarms. So this is the typical structure. So we have the panel at the ATM, we have the alarms answering machine, we have the siren, we have the detectors, of course. Then we can have also the M-bus and expansion of this alarm over the network so that at any given point, the alarms can be accessed, whether it's physical or remotely. Then of information overlay, we have a POS system. So based on the camera that we get, we'll overlay the transactions that are happening through DSS, and we can always use this to help to solve challenges of conflict at the ATM. We have the two-way communication. So we have a panic button here and an SOS button. So you can call so that we have an assistant, a bank assistant helping you in case you're facing a challenge at the ATM. At the same time, we have a panic button in the event where we have incidents at the ATM. Then at the network center, we have different roles that are played by the monitoring center, and we do response based on the linkage that is provided at the ATM. So this is foolproof security for our ATMs at the bank. And some case studies. So we have smart ATM protection, which has helped in Japan to curb fraud. Event timely discovery rate increased by 80% using our AI. So this is a typical application in an ATM. Then we have equipment distribution, where we have, where do we put what product? Inside the ATM area, we have the dome camera, we have a motion sensor, we have ATM, AI and VR, we have an exit button, an emergency button, we have the intercom next to the ATM, we have a siren, then we have the secure area, where we also add extra cameras to supplement this. So we are doing 4 components within the same solution. Video surveillance, we have an alarm system, we have an intercom system, and an access control system. So that is our ATM security. Then let's highlight some key products. DSS Professional, which is the video management system. We have the dual lens AI network camera. We have the pinhole camera. We have the face recognition access controller, the EI5 NVR. Then we have the alarm box. We also have the emergency station. We have the master station for the security team. We have the shock detector and vibration sensor as alarm detectors. We have the corner network camera, which makes it even hard for anyone who is trying to vandalize it. We also have smoke sensor in the event maybe that happens as an incident. So that covers our introduction to our finance solution and ATM. And because of the interruption, I'm going to recommend that we repeat this training tomorrow. So we are going to create time and share the training schedule so that we repeat the same thing, then we can take questions. As at now, if you have any question, just feel free to unmute and share. Then I'll be able to respond, but just note that we are going to repeat the same training for efficiency reasons. Any question? Or you can also write it in the chat feature and I'll be able to respond to it. So I'll take a minute so that if you're typing, you just write it there. If you need access to this training material, just leave the email address in the chat and I'll be able to share the summary of the same materials. So that marks the end of this training, and thank you so much for your time. Do we have any questions? I can't see anyone unmuting. So we are going to end this training now until tomorrow when we repeat the same training. So thank you so much for your time, and let's look forward to tomorrow. Thank you.